everyone, this is Dr. Zach. Today we're going to practice our u substitution once again, and we will work with definite integrals. Let's begin. From your lesson preview, you should have recognized that u substitution does not always work. If you had let u equal 25 minus x squared, du would be negative 2x dx, and your dx value, once you substituted, would not help you get rid of that x in your denominator. So this problem was a reminder that sometimes geometry is the way that you want to integrate. You recognized your semicircle. You used the formula. Area was 1/2 pi r squared. The radius in this problem, of course, was 5. So there's your 5 squared. And don't forget, there happened to be a negative in front. Now, for example, or for question B, did you recognize that you needed to use the second fundamental theorem of calculus in order to solve question B? So when you find the derivative of the antiderivative, first you substituted in your 5x. You get the absolute value of 5x squared and plus 5. Next, you wanted to remember to multiply by du, and that would be times 5. So you should have the absolute value of 5x squared plus 5 times 5. Simplify if you feel like it. This becomes 25x squared plus 5, but once again, remember this is all multiplied by the number 5. Alright, so after question B, let's look at example 1. You're asked to determine the area under the curve. A quick sketch will show us that when we look at our curve, when x is 1, the y value is 1. When x is 5, the y value is 5 over 3, so a little bit higher. This is a continuous curve, and we're looking for the area trapped between 1 and 5, as well as the x-axis. So the area is going to be equal to the integral from a to b of our function f of x dx. For this problem, we're going to let u equal your 2x minus 1. du is going to be 2 dx, which allows us to do our substitution. dx is du over 2. All right, so the difference with the endpoints, please recall that these endpoints are x values. They are x values. So when we do our substitution, you're going to have to account for that. I'm going to choose to keep my x values for this one. X equals 1. X equals 5. Recall, I told you there were 2 different ways to do it. In this example, I will keep the x values. I rewrite my problem. I have x over u to the 1/2 power is multiplied by du over 2. I do have to figure out how to get rid of this x value, otherwise I cannot integrate. Notice I can solve for x to give me u plus 1 divided by 2 is x. So now we're going to substitute and get our x equals 1 to x equals 5. We have u plus 1 over 2 times u to the negative 1/2 du over 2. Simplify some more before I integrate. Remember, algebra makes this so much easier. Do your algebra as you go along. I have u to the 1/2 power minus, no, that's a plus, u to the negative 1/2 du. All right, so this is equal to 1/4 times u to the 3/2 multiplied by 2/3 plus u to the 1/2 times 2 over 1. Now, remember, these are x values. X equals 1, x equals 5. Because they're x values, we will need to replace the u's with that 2x minus 1. So we'll have 2x minus 1 to the 3/2 times 2/3 plus the quantity 2x minus 1 to the 1/2 times 2. Now we're ready to substitute the 1 and the 5 in because these are the x values that we were looking for. Place the 5 in first. You're going to end up with a 9 to the 3/2 times 2/3 plus, you will have 9 to the 1/2 times 2, minus, put your 1 in, and you will have 2/3 plus 1 multiplied by 2. When you simplify, you should come up with a nice 16/3. So as you can see, for example 2, we're looking for an average rate of change. So g of x average, as you'll recall, is going to be 1 over b minus a multiplied by the integral from a to b of g of x dx. So the average value of our function is going to be 1 over your pi over 4 minus 0 times the integral from 0 to pi over 4 tangent of x dx. Always check your domain. Notice we're going from 0 to pi over 4. That is continuous for your tangent function over our given interval. Now, tangent function. You don't know the antiderivative of a tangent. So we're going to do a little bit of algebra to solve this problem and rewrite the problem as the sine of x over cosine x. Knowing your trig identities is going to be very useful. So for this problem, let's let u equal the cosine of x. du is going to be negative sine of x dx. So that tells us that dx is du over negative sine of x. Look what conveniently will happen. When we substitute for our dx, we're going to end up with 4 over pi, the integral. Now I'm going to change those to u values, but first let's see what happens. We have the sine of x over u multiplied by du over negative sine of x. So very conveniently, the sine of x is canceled. As I said, these are x equals 0, and when x equals 0, u is going to be equal to the cosine of 0. Now, what is the cosine of 0? Of course, you know that would be 1. So u is equal to 1 when x is 0. Next, we're going to let x equal pi over 4. So what does u equal? U equals the cosine of pi over 4, which is the square root of 2 over 2. So for this problem, I chose to change the endpoints just to give you a different perspective. We're ready to integrate now. So we're integrating from 1 to root 2 over 2, 1 over u du. So I don't know if you recall, that's why I'm going to remind you. The integral of 1 over u du is equal to the natural log, the absolute value of u, plus c. Remember when you took the derivatives of the natural log? Well, now they're coming back with antiderivatives. So continuing with our original problem, we now have 4 over pi natural log of u, the absolute value of u, evaluated from 1 to root 2 over 2. When we substitute, we're going to end up with natural log root 2 over 2 minus the natural log of 1, which of course is 0. So for this problem, there's a lot going on, but I chose to demonstrate substituting the x value to use u's at the end. Now it's time for you to practice. So give questions 1 and 2 a chance, as well as the problems on the next page. Afterwards, we'll discuss some of your answers. There are actually 3 different ways you could complete question number 3. U could equal sine of x, u could equal cosine of x, or you could use some algebra and rewrite the problem using the identity sine of 2x equals 2 sine x cosine x. For question number 4, to determine the area, this was an annoying little problem, as you probably figured out. Let u equal x plus 2, which lets us know that x is equal to u minus 2. We'll substitute. Don't forget, you've got to get rid of that x squared. In order to get rid of x squared, you replace it with your u minus 2 quantity squared, multiply it out, and then integrate. We know that this area is going to be equal to 0 because of symmetries about the origin. Now for number 6, Which of the following is equivalent? I hope you came up with C. Number 7 is a reminder that we can use trapezoids and Riemann sums in order to calculate the area under a curve. Also, we know that when we integrate the absolute value of velocity, you're given total distance. And when you integrate velocity, that's going to be displacement. As you look at number 9, you're asked to think about the flow rate in gallons per hour. So when you're looking for the amount of water, that would be gallons. That's going to be the integral from 0 to 24 of the rate. For today's exercises, make certain you get some practice with your U substitution. This is a very important topic. Practice on page 302. Look at the odd questions, and you have a fabulous day.